All right, before we get started on not chapter 5, example 5, let's go ahead and talk about some vocabulary. So a scale, what that is, a scale is a ratio, so like a fraction, right? A ratio between two sets of measurements. Okay, such as 1 inch to 5 miles. A lot of times they have this on maps. So if 1 inch on a map represents 5 miles, so that would be the scale of the map, okay? Now, a scale drawing or scale model uses a scale to represent an object as smaller or larger than the actual object. So that happens a lot with, maps or just different types of models or drawings that people make. They like to make them according to a scale. So let's look at some different examples involving this. So, all right, we have scale drawings and scale models. So a contractor, okay, has a blueprint. So a contractor is just a person that likes to build stuff, right? Or that builds stuff. You hire them to build things. A contractor has a blueprint for a house drawn to the scale of 1 inch to 3 feet. Okay, so that we have 1 inch to 3 feet. I'm just going to go ahead and write that down. It says a wall on the blueprint is 6.5 inches long. How long is the actual wall? So what we're going to be doing is setting up a proportion, and it gives us this information, 6.5 inches. So does that go on top with the inches information, or does it go on the bottom with the feet information? And you're right, it goes on the top. So 6.5 inches, right? And it wants to know how long is the actual wall. We don't know that, so we're going to make that X. Okay? So what we can do to solve this is we can use we have a proportion. We can just use our cross products property, right? In cross products property, and just go X times 1, which is X equals 3 times 6.5. And I'm not sure what that is right off the bat, so I'm going to do it over here. 3 times 5 is 15, write the 5, carry the 1. 3 times 6 is 18, plus 1 is 19. And there's 1 decimal spot, so we put 1 decimal right there. So 19.5, and it's talking about feet. So that's how much the wall is, 19.5 feet. All right. Nice. Okay, let's look on the next one. So, it says one wall of the house will be 12 feet long when it is built. How long is the wall on the blueprint? So we're going to use the same thing, right? 1 inch equals 3 feet. But now what they're telling us is that the wall is 12 feet. So does that information go on the top or the bottom? And it goes on the bottom. It goes where the feet go, right? So 12 feet. And we want to know how many inches that is, so we don't know that, so that's going to be our X. So we're just going to use the cross products property, right? So 3 times X is 3X equals 1 times 12, which is 12. And then we just want to get X by itself, so we divide both sides by 3. And we end up with X equals 12 divided by 3 would be 4, so it would be 4 inches on the blueprint. That's how big the wall would be. Perfect. Okay, let's go on to our next problem. It says a scale model of a human heart is 16 feet long. The scale is 32 to 1. So 32 to 1. How many inches long is the actual heart represent? So this is going to be 32 feet to 1 inch, because we know the human heart's small and it's going to get bigger, right? So we're going to go inches to feet like that. So a scale model of a human heart is 16 feet long. Okay, so where does that information go? Well, it's going to go up here on top. The feet is going to go with the feet information, right? And then we don't know how big the actual heart is, so we're going to make that X, okay? And then we're just going to do the cross products property. So we have X times 32, which is going to be 32X equals 1 times 16, which is just 16. And then we got to get x by itself, so we divide both sides by 32. And then we go up here, 32 divided by 32 is 1. 1 times x is just x. And can we reduce that? Yeah, I think 16 goes into both. 16 goes into 6 one time, 16 goes into 32 two times. So our answer is 1/2 inch. So how many inches long does the actual heart represent? 1/2 inch. That is not that big at all, is it? So there we go. Okay, let's go to the next one here. It says the scale on a map of Virginia shows that 1 centimeter represents 30 miles. So we have 1 centimeter representing 30 miles. The actual distance from Richmond, Virginia to Washington, D.C. is 110 miles. On the map, how many centimeters are between the two cities? So we have 110 miles. Where does that go? That's going to go on the bottom with the miles information. And we want to know how many centimeters. We don't know that, right? So that's going to be our x. And then we just do the cross products property. So 30 times x is 30x equals 110 times 1 is just 110. We want to get x by itself, so we're going to divide both sides by 30. Okay, 30 divided by 30 is 1. We go up here, it's going to be x. Excuse me. And then we want to simplify this, right? There's a 0 on the end, that means 10 goes into both. So I'm just going to cancel out those zeros, and we're left with 11 divided by 3. And because we're talking about centimeters, I'm just going to go ahead and put that in as a mixed number. So 3 goes into 11 3 times with 2 left over. So it would be 3 2/3 centimeters. That would be how long it would be on the map. Awesome. So that is it for this section, and I will see you again with the next section. All right, have a wonderful rest of the day. Goodbye.